Hi guys, I hope you're doing absolutely fine. Welcome to this video on protocols and extensions. We'll start learning about protocols and then we'll look into extensions. Protocols essentially are a blueprint of properties, methods, and other requirements that a type must conform to. If a type decides to adopt a protocol, then it must implement all the properties, all the methods, all the requirements which are defined inside a protocol. In this video, we'll dive deeper into the concept of protocols and extensions. We'll also look at a lot of doubts and a lot of questions, you can call it, that everybody generally has. So we will dive deeper into those questions and we will look at this concept from all the perspectives. So grab your Xcode and let's get started. So we'll start with what protocols are. I will mention it here. A protocol is blueprint of methods. A protocol is print of properties, methods, and other requirements that a type must conform to. Think of it as contract. If type agrees to adopt a protocol, it must implement the requirements defined in the protocol. Let's see how to define and use a protocol. I will create a protocol here. Triable. So protocol can only have properties of type computed properties. Here we are mentioning it can be a read only computed property or read write computed property. Here we want whatever the type that will adopt or conform to this protocol will must have a read write implementation of this value, this property. And regular functions accelerate and brake. These functions are here without the body. So one of the questions that arises in mind, can we have a method implemented, in the sense a method with body inside a protocol? The answer is no. And let's create a structure for it that will adopt or conforms to this protocol. So here I've created a structure car which is conforming to the protocol drivable. Now that the car conforms to the protocol, it must implement all the requirements which are defined inside the protocol, which is a property and two methods. So this property will be having this value assigned, or we can not assign it here, rather it will have init hidden here. We can see it as well. So when we will create the object of car, we will give it a value and we are implementing both the methods as well. Let's create its object. And I will call both the methods. Let's run this. Okay, we forgot to give initial or initializer. We forgot to give a value here. Let's run it. And that's it. Let's move on to the next thing. That is protocol inheritance and composition. So here, if we will talk about inheritance and then we'll talk about composition. So protocols can also inherit from another protocol. I will mention it here. Let's write an example for it. In this example, we have a protocol vehicle which has a property read-only property name, and here we have a protocol electric vehicle which is inheriting vehicle, and we have battery level, the property of electric vehicle of read write type, and that is how inheritance really work in protocol. Also, let's talk about composition. We can also combine multiple protocols into a single requirement using a composition. That is, I will mention it here. I will create a function here, and here I can give the protocol type as the type of the parameter so that we can pass the object which is conforming to both the types here. So I will mention vehicle, and let's mention drivable and vehicle. So we have a vehicle protocol here and a drivable which we have declared up here. Now I will create a structure which will conform to both. I will complete this function. Inside that we will print something like driving the vehicle, and we will access the property of vehicle which is name here, and speed which is going to be the property of drivable which is here. Now let's create a structure. I'll name it car1 so that it does not clash with this structure, and let's make it conform to vehicle, also drivable. Let's put it first, and inside here we will implement all the requirements of both the protocols, that is drivable and vehicle. So here we have these many requirements. I will copy them first, paste it here, and here we do not, I will not give anything inside here. I'm just implementing, and we are just implementing the drivable all the requirements. Now let's look at the requirements of vehicle, which is name. So I will take this here and mention it here, and that's it. Now we are implementing all the requirements of both the protocols. Let's create object of it and call the function drive, and we'll pass it to that. So we'll give name, and now I will call the method drive, and here it is expecting an object of any type. It could be structure, enum, or classes, which is conforming to both the type, that is drivable and vehicle. So I have the car, which is a structure type, conforming to both. So I have created its object, and I will pass it to as an argument to the vehicle. Now what will happen is it will execute the function body, and it will print us this. I will also mention it here, but first let's run it. Okay, we have an extra parenthesis here. Okay, this parameter should come first since it is the first parameter. Let's run it now, and it gives us driving the Honda at speed 140. We gave Honda 140, and it is saying driving the vehicle, which is Honda, and at a speed, vehicle speed, which is 140. And this is what composition really means. That is, you can take multiple protocols in the parameter as the parameter type. You have to use and, but when you are making a type, that is structure, class, enum, confirm both of them, both the protocols, you have to give a comma. I will mention it here. This function requires any type, and by any I mean class type passed to it who conforms to both the drivable and vehicle protocols. This ensures the type has all the required properties and methods. Now let's learn about one more thing, that is type alias. Now type alias, we have seen it before. Type alias is basically a alias for your type or another name for your type. So what I will do is copy this and create a type alias here. I will name it Reusable vehicle and paste it here. That's it. I can copy this and replace the whole thing with the alias we have for it. Now let's run it. And it gives us driving the Honda at a speed 140. Everything works completely fine. Also, when you are confirming multiple protocols with the help of a comma, there also you can use this alias. So what I will do is copy this and paste it here. But before that, notice one thing, in the type alias, we have the and mentioned here, but here we are using comma. So this will actually will still work. Let me just copy this and paste it here. Although there is a comma and inside the alias we have and, it still works. Swift actually just knows when you are using a type alias here. So it's working fine. It is giving us this because Swift already knows or infers on the type alias that you give here, whether it has a comma or and it doesn't matter. It knows that you are just trying to confirm both the protocols. You're trying to make the type conform to both the protocols. And that's it. I will mention it here. And that's it. Let's move on to the next, which is extension. Now, before we start with extensions, there are two questions that we will address just in brief as of now, because when we are going to look at the questions here, we will address them in detail. So the two questions are, the first one is we have been using struct all the way and we are making it conform to the protocol. What about classes? What about enum? And what about all the other types which can conform to the protocol? So the question is, what all types are there? Because there are collection as well, that is array, set, dictionary. There are tuples as well. We will see what exactly the number of types are there which can conform to protocols. And the second question is the requirements of the protocol. That is, right now we know property methods could be the requirement of the protocol, but what all other things are there which can be considered as the requirement of protocol? What about subscript? What about INIT? So we will see the whole list of the entities or things that can become part of the requirement of the protocol. But again, in the end, we will see these two questions in pretty detail. So for now, I'm just moving forward. We need a basic understanding of extensions as well. So let's continue. Now, extensions are the way to slide in a new functionality without touching the existing code. Here, the structure, the types, structure, classes, you can extend them, and also you can extend protocols. So let's see one example here. Here I will mention. So here I've mentioned extensions allow you to add new functionalities to existing type, whether they are classes, structure, enum, or even protocols without modifying their original implementation. That means however they are at the moment, we will not touch this code and still we'll be able to add a new function, new property like that. Okay, when it comes to property, in extension, we are not allowed to give stored properties, but when it comes to functions, yes, we can do that. Let's see an example now. So I'm creating an extension of drivable here. So we have created this drivable right here on the top. This is a protocol. What if I want to add a new method here? So first we are taking a look at protocols, how to use extension with protocols. I've extended the protocol derivable. We have to use the keyword extension and the name of the protocol. Now this protocol is defined right on top here. It has speed, acceleration, and brake. Now, what is the agenda behind extending protocols? Well, if there is a type called structure or class, when we make this type conform to a protocol, it is mandatory for that type to implement all the requirements of the protocol. But what if we don't want to? We don't want the class which is conforming to the protocol to must just give implementation for all the requirements. So we can create an extension to the protocol and give some default definition to all the methods here. Let's see, we have two methods here, accelerate and brake. I will copy this and here I will give them some definition, which will be the default definition. And after this, it is not mandatory for any type which will conform to this protocol that they must give implementation to these both the methods. Let's see. So here I will print. So I have given a default implementation. Here I'm just printing the vehicle accelerate, and here as well something to print. Now let's create a class here. And I will make it conform to this protocol drivable. And here you will see it is just throwing one error, that is there is a property as well. Let's go on top. There is one property speed. So I will take this. So when it comes to requirement property, we must implement it. I will give it some default value. But when it comes to method, because it has the default implementation, some default definition to it in the extension, it is not giving any compile time error, and we will run it as well to see if it gives any runtime error. Let's run it. And as of now, it's not giving. Let's try creating an object of vehicle. And we will access speed. Let's run this. And it gives us 10. That means it is working totally fine. But if this default implementation was not here, let's comment it. And now let's run it. It gives you the error at compile time as well as at runtime, saying that protocol requires function break, and type this add stub. And when we add stub and give something in the definition as the definition of it, after that when we run, it won't give any problem. So this is the agenda of using extension with. So when we use extensions with protocol, this reduces boilerplate code for confirming types. Here the confirming type is class. And let's move on to the classes. I will create extension of class structure car. So we have the car declared here. It's a structure which conforms to drivable protocol. Here I can extend car, and if there is a new functionality, a new feature is coming up, we can add a function for that here, just like this. Let's say honk, and I'll print the car honks. And that's it. We can access it as well. So we have the object created already, that is my car, that is the object of car. Now we haven't touched this existing code of car here, and we are still able to slide in a new functionality, that is honk, by extending the car. Now let's access it, honk, and we can just simply access it, and let's run this, and it gives us the car honks. And that's it. That's how easy it is. I will mention here the example of class. And here the example of extension with protocol. We can also combine extensions and protocols. So let's see that. Here I have created an example protocol readable. It has one property, which is a read-only property, and a function read. Another protocol landable, which has one function, and it has the parameter person of type string. So we have two protocols, and we are extending both the protocols one by one, that is extending readable, extending landable, and we are just giving default implementation to the methods. Now here we have a structure book, which is conforming to both the types readable and landable, and it has its own one property, that is title. We are creating the object of book with some title here. This is the object which we are actually using to get access to both the methods. Now here we have created extensions of the protocols, and which has been confirmed, and the book is confirming readable landable here. We can do extension book, and here also we can confirm to both the protocols, and we don't have to implement the method since we have a default implementation in the extension of the protocol. If we run it now, it should still work, and it gives us reading Swift programming lending to Alice. And that's it. That's how we use extension and protocols combined. So here we are extending the structure without needing to touch the existing code, and here we are giving default implementation for the methods of the protocol without disturbing the existing code of the protocols. Now that is it. Let's move on to the next one, that is the best practices for protocol and extensions. Here I will mention some points. So let's understand them one by one. So we use protocols for abstraction, define common functionality across different types using protocols. And the second is leverage default implementation. We should always have some default implementation to the methods of protocols, and use extension to provide default behavior to protocols, reducing repetitive code. Avoid overusing protocols because it may mess up. So only use it when you truly feel the need of using the protocols. You can use extension for making your code more organized, modular, and you can add the functionality to types without modifying their original definition. That's one advantage of extension with classes structure, and giving default implementation is the advantage with protocols. Now let's move on to the next one, questions. So when it comes to questions, these are the very widely confusing questions that everybody had. So we are going to cover them in a broad manner. That is, when it comes to what all types can conform to protocol. So when it comes to questions, the very first question that these are the few questions basically which everybody has first of all. Now, at some point when you are learning protocols and extensions, you have these minor doubts, and when you combine them, it actually narrows down to one single big doubt. So we are actually taking these questions which will resolve all, starting with the first, that is what all types can confirm protocol. So I will mention it here. Now, when it comes to what all types can conform to protocol, here I have mentioned the types. We know about classes, structure, enums, but tuples are also something which cannot directly, but there is a way that tuples also can conform to the protocol type. Extensions, we have just seen one example, that is book. We have extension of the book, and then we make it readable, make it conform to the readable and landable protocol. When it comes to collections, we have array set dictionary. That is also something which can extend and can conform to protocols. Optionals are also something, let's say you are using a type integer optional as the type of property, then you can extend the optional and give some method there. We'll see this in detail in an example of it, but you can use that method inside an extension of optional with that property all along throughout your project. So we'll see this in detail with the help of an example. Generic types and associated types are the two things which we will see in a total separate video when we will learn about generics first. So once we have the understanding of generics, then we will understand associated type and we'll see it in very much detail. So we will leave these for this video and we'll leave this for that video. But here we will see a simple example so that we get acquainted with the concept just to have a gist of it. Now let's move on to the next question, which is what all requirements protocol can have. So we know about properties and methods. What else? Can we give subscript? Can we give initializers inside protocol so that whatever the type that will conform to that protocol will be implementing these requirements? So we'll see all the types, all the kinds, all the things that we can actually make as a requirement inside the protocol. I'll mention it here. So here I've mentioned requirement. So we have this many categories of requirements. I've added a description to it and an example. So this note will be useful right after we are done with seeing examples of each type of requirement. So starting with properties, we have instance properties, which are the computed property, read only, write, read write property. We can just declare it like we have seen, the variable speed and the type and the get and set. So these are essentially the computed property. If we go up, we will see here we have declared variable speed and get and set. So this is a read write property. If we remove set, it's just a read only property. I will undo this so that this will be the notes. And the next is static properties, where we use static keyword and so that we can make the property read only or write only property inside the protocol. All we have to do is just take the instance property or the read write or read only property and add the static keyword in front of it. And this would be the example. We will see this in detail. The next type is method. We have seen regular methods in previous examples, and there are static method as well, that is we make it static and we can just mention this much in the protocol and whatever the type will conform to it, we'll implement it. When it comes to subscript, so we can either, so we create subscript like this inside a protocol, and we know that the subscript has get block and set block that we used to read and write to or gain easy access to the property inside class or structure. Next is initializer. So we have seen a lot many types of initializer. When it comes to regular one, that is in structure we have the default initializer, and in class we have designated initializer that we can mention inside the protocol. And the next is failable. Failable, if you remember, there is a question mark, so that becomes a failable initializer. We can just mention something like this in the protocol, and the class must implement it. So here we have seen, if we take a look at one example here, so let's say we have this example vehicle, and this is the protocol which is being implemented, which is basically part of the type alias, and drivable is another protocol. So when it drivable vehicle type alias, that is the two protocols is been implemented by car1. When it comes to car1, it gets a free initializer like this. Structures come with initializer. So if I want this initializer, to be mandatory for the structure car1, all I have to do is mention this initializer inside one of the protocols of this type alias, either in drivable or in vehicle. I will go and mention here the signature of the initializer. Now it's mandatory for the car one, since it is conforming to the protocol vehicle, mention the initializer. If I remove it, and I should get a compile time error, but right now it's just processing it. Let's try running it to expedite this process a little bit. So here right now it will not throw any error because structure has it hidden. If I change this just speed, then it will throw this error saying type car1 does not conform to the protocol vehicle, and we must implement this. So I will say self.speed, and it will go away. And that's how you implement. I will just undo everything so that these will be the nodes only for the things we have been learning. And now let's get back to the question, that is initializer. The next is optional. So we can use add object and use optional keyword, and after that we can declare a method like that. And optional is something that you can also make as part of the requirement of a protocol. We'll see this in detail with the help of an example. Next is associated type. So this is something that we will learn again in the separate video. We'll have a video on generics. We will talk about generics and associated type, and we will understand in deep how, but we'll definitely see one example here of it so that we get acquainted with the concept of associated type here. And now let's move on to the next question. That is, can we define method with body in the protocol? The answer is actually straightforward. That is no. We cannot. We have extensions for that. We can create an extension of the protocol and define a default implementation of that method inside the extension. I would make it more specific. Let's copy this and here I'll mention an answer. So question 3, we have 3 scenarios here I have given when we are declaring a method without a body type. So that we can mention in the protocol just like this. And we can declare a method with a body that is not allowed, providing a method body in a protocol extension. And this is the way you can give a body with method with a body for a protocol. And let's move on to the next one. That is, what all types of properties can we give in protocol? So we know that there are about 5 types of properties we talked about in previous videos. First is stored property, inside which we talked about the variable stored property and let constant stored property. We know about the computational or computed property, which can be read only computed property or read write computed property. We talked about also the property observers. We talked about lazy stored property, which is just a lazy keyword for the variable stored property, and the type property where we use static keyword. So let's understand what all types of properties we can actually declare inside a protocol. So I'll mention it here. So the question 4, we have seen, just to get a just to remind you guys that we have seen these many types of properties in previous videos in very much detail, and we'll just take a look and revise it quickly. Stored property were var and let. This is called variable stored property, and this is called let constant stored property. Lazy keyword is just for variable stored property, and that's called lazy stored property. Computed property, where we had get and set block, if you remember. If we have only get block, it's a read only computed property. If we have both, that's a read write computed property. We have seen property observers, that is the will set did set block that we use to observe the change inside a stored property, and that too variable stored property. And the next is type property, which is static keyword basically that we use in front of property to tie it up with the type itself. The type, I mean class structure, like that. And now let's talk about the answer. After all, property type, let me give here one space as well. So here I've mentioned all the property types, and as you can see, starting with here I've mentioned can be a protocol requirement or not, and the reason why if it cannot be. Starting with the stored property, it cannot be given in a protocol, and because protocols do not manage memory and cannot declare stored property. When it comes to lazy stored property, it is just a lazy keyword for stored property. Since we cannot have stored property, we cannot have lazy stored property as well. When it comes to computed properties, we can have them declared inside a protocol. And all along so far we have been seeing, if you see this example, this is the variable speed, which is a read write stored property. If you remove set, if there is no set block, it's a read only computed property. Let's get back to the answer. And so when it comes to then property observer, so we use property observer to observe the change in the stored variable stored property. We have a set did set block there. Since we do not have stored property inside protocols, we cannot have property observer or type with property observer inside protocol. And the finally type properties that we can mention inside protocol, and we'll see these with the help of examples. Now that we are done with understanding all these 4 questions, we'll take one step further and we will understand examples of each, that is starting with what all types can confirm protocols. So let's start with each one of that. We've seen structure, classes, let's see enum and further, and then we'll jump and understand better with the help of examples the second. Now let's take a look at example of each of the type that can conform to protocol. Starting with the very first, classes. So here actually I have returned all the code beforehand so that we can focus on just understanding. And here, starting with classes, we have a protocol greetable where we have a function, a regular function greet, and a class person conforming to that protocol and also implementing it. And when we create an object and call the method, we will receive the output. I will comment everything below. Let's go up to our example and we will run it. And we get hello, I am a person, which is this string. For the output to be clear, I will comment everything on the upside as well, so that we will have our output clean. I will clear it and run it now. And we are getting one single line, hello, I am a person. Now let's go to the second one. So I will shift this, we'll shift it to here. And let's understand how structure conforms to the protocol. We have a protocol drivable2 with a read-only computed property, max speed, and the structure car2 is conforming to the protocol drivable2, and also implementing the property max speed here. We can create its object car2 and we can access the max speed. Let's run this and it will say car's max speed is 200 km/h, which is this print statement. Now let's move to the third, which is enum. So I will bring it here. In enum, we have the protocol identifiable. It has one read-only computed property ID. And just a quick reminder, protocol can only have computed property or type property, which is using the static keyword. Now getting back to the example, this ID is the read-only computed property, and we have the enum animal, which has cases dog, cat, bird. When it conforms to the protocol, it will have to implement ID, and we have a switch statement which will based on self, that is we're creating the enum animal dot dog, so this becomes a value, and then we are using animal dot ID, so animal becomes the self here, and based on that we are going to get the string, and that's it. Let's run it and we get animal ID dog. Now let's move on to tuples. I will bring the comment here. Now tuples, as we have seen in our notes, it is something which we cannot mention it inside the protocol. We have to be indirect, and let's see what it means here. Now we have a protocol summable, so we don't have a tuple here anywhere inside summable. The indirect way is the type that will conform to the protocol summable. There we can have a tuple type. Now we have learned in the video of data types that tuple is also a type, so we can just assign it as the type to a let or where property. And now we can make our structure conform to summable, where we can have a function which is related to this tuple, that is calculate sum. It will calculate the sum of all the values inside the tuple, and then it will implement it, inside which I'm accessing the tuple, and dot 0 will give me the first value, dot 1 will give me the second, and dot 2 will give me the third value. We can sum it up and just return it. I'm creating the object here with some tuple values to the property of the tuple calculator structure, and then we are just calling the function. It will return us the sum of 15, 8 and 4. Let's run it, and it gives us the sum of tuple is 27, and that's it. Now we can move on to the next one, that is extensions. Now this is something we have seen before. I will bring this down. So I have not written any example here as we have seen it just yet. If we will go back to our last example, that is readable. Here we are extending the book structure and confirming to the two protocols. Hence, extension can confirm to the protocol. I will bring this, actually I will bring the whole example. I will copy it and bring it here. And paste it so that it will be good for our reference. So anytime when you will revise this topic, you can just go through the examples one by one. Now let's move on to the next one, that is collection. Let's move on to collections. So we have array, set, dictionary, how they conform to a protocol. Let's see that. So here we have an array, and to make it conform to a protocol that we created, that is countable here, which has one read-only computed property. All we have to do is use extension and create an extension to an array. Now this is a predefined type. This is our collection. And after that, we can just make it conform to our protocol. And now after that, we can create a let constant of type countable, create some values of array type, and we can access the count. Now you must notice that we are not implementing count here because it's already there in array predefined type. So we can directly access it like numbers.count. Let's run it. And it gives us count 3. The next one, that is optional. So I will bring it down. Now, when we talk about optionals, I've replaced the example with a better one. Let's say we have a let constant property integer, which is integer optional, and we are assigning a value here for now. And we have another let constant named nil number, which is also integer optional, where we have assigned nil to it. Now, this is the optional type. What if like string and integer, these are predefined types. For optionals, there is a predefined type called optional to which we can create or to which we can extend a little bit. And then inside that, we can give a method that is debug print here, where we will have a switch case that is based on self. It will check self is going to be number here, like we are using number.debug. So number is going to be the self here, and we are going to check if it has a value or not. That is, if it has value 42, it will be captured in the associated type here in value. And you must be wondering, what is dot sum here? Well, this is a optional case. You can imagine it like this. There is a enum named optional, which has two cases, none and sum. Sum is associated type case, and none represents absence of value, sum represent presence of values. So for case dot sum, we will capture the value if the self has it. So the self number, which is 42, has it, will be captured in value here and will print it. For the case none, which will be for nil number, so nil number dot debug print, nil number is going to be the self here, and there won't be any value that is going to be nil here. So we are not going to capture it and just print nil message. Now this message is something we will expect in the parameter. If it's not given, we will say value is nil. So right now we're giving no value found, so we will receive no value found, and in this case we will receive 42. Let's run it, and we get value 42, no value found. I will comment the previous examples for cleaning the output for further examples for us. And let's come back to our optional. Let's run it once again, and we're getting value 42, no value found for these two debug prints. Let's comment it, and let's move on to the next one, that is generic types. So now let's understand generic types. Now generic types is something that we will see in a separate video for sure, but for here we will just understand the basic of it, not diving much into this. Even if you don't understand the whole of it, don't worry, that one separate video is going to cover this in very much detail, and where I'm going to be writing the code in a way that you will actually understand the things step by step. So here, just a quick glance, we have a structure stack here, and it has a property items and two methods, push and pop. Now you will notice the type of the property items we are not sure, so we just put t here, and in the method push and pop we are expecting an element of type t and returning an element of type t. Again, the mutating keyword is here. So in structure, since the structure is value type, if there is any method inside the structure which will make change to the property of the structure, we will mark it as mutating, and that's it. The push is basically appending an element inside the items, and it is just popping the element from the items. Now let's talk about protocols. The protocol stackable has been confirmed by stack, and this type will be gone as the associated type and will be captured by element here, and that we can use to mention the type of the element we will expect for the method that we want to mention inside protocol. That will be must for the stack to implement, and also the element for the pop. And that's it. When we're creating the stack object, we'll mention the type, and it will go all the way to this t and to associated type element here. We are pushing two values, and then we are popping. Let's run it. We should receive 20 here, and we'll get 20. Now let's move on to the associated type. Now in associated types, we have a protocol, pair protocol, which has two associated type, key and value, that we are using as a type of key and value read-only computed property. And here we have the structure pair, inside which we have two generic types, k and v. So here we are using type alias key for k type and type alias value for type v. And we have two properties of type k and v generic type. It is conforming to the protocol, and the associated type will be capturing k and v here. We're creating the object of pair structure with key as username and value as John Doe, and then we are just accessing them. We can run it now, and it gives us the key and the value. Now the next is the second question. So first of all, I will comment all of it. So these were the examples of all the types that can conform to a protocol. And these are the notes that will help you understand it better. So whenever you will revise, just go through the code and the notes, and you will be having quite a good understanding all the way from the start to end. Let's go to the next question. That is, what all requirements protocol can have? Properties, methods, what else? init subscript. So let's talk about that now. So we have seen what all requirements are possible, which are these. Now we will see examples of it and understand it even better. So here I have mentioned example of question 2. First we will see property. Inside that we have two types of properties. Instance properties, which is basically computed property, and it could be read-only computed or read-write computed property. And also static property, where we use the static keyword to mark the property as static. Now I will bring this from here down to here. Now in properties, the instance properties are basically computed property, and we have read only and read write property. So here I've created name and speed. Name is get only or say read only property, and speed is get set, which is read write property. I've also created static, that is the second thing, although we will see one more example about the static property. It is also known as type property, right? So we have seen 5 types of properties. Computed and type properties are 2 of them. The other are stored, lazy stored, and property observers. Now here we have created a structure car3, which is confirming to the protocol vehicle 3 and implementing the 2 properties and 1 static property. The static property is initialized here, or say the value has been given, because it is tied up with the structure here, and it cannot be initialized using an initializer. We have seen this very much in detail in the initializer video as well. Now if you will unhide the init from here, you will see only name and speed is been initialized using the init. I will undo this, and then we are creating the object car3 with some value of name and speed, and just accessing name, and also accessing vehicle type, that is the static property, using the car3, that is the type name itself. And that is how properties can become a requirement, that is requirement of the protocol. And let's look at one more example about the type property, which is the static property. So I have a protocol identifiable 1, and we have 2 static. Here we have 1 static property, and the next one I created not a static property, rather a static method. Now static method is there. Again, both of them will be accessed using the type name, the type which will confirm to the protocol identifiable 1. So user is confirming to the protocol identifiable 1 here and implementing both. In generate ID, all I am returning is a string which will be identifier property, that is user, and some random value of integer from 1000 to this. Any value will be picked and will be given here. We can run it. We will receive sedan, land vehicle, and let's see what it returns when it comes to random values. Let's run it. We get sedan, land vehicle, and user 3016. If we run it again, it will give you another different random value this time. Now let's move on to the methods. So let's go up, and in methods we have learned instance method or regular methods and static method. We have already seen static method here. Generate ID is a static method. But let's see one more example. So this is a protocol flyable which has a regular function or regular method, also known as instance method, and a static method. And bird is conforming to the protocol and implementing both. Now static method again, we are giving a value here by ourselves, and the fly is printing flying high. We created the object and accessing fly, and we are using the type itself to call the max altitude method, static method. Let's run it, and it gives us flying high and 1000, which is the output of fly and max altitude. So this is how method also can become part of the protocol. So method becomes a requirement that we can mention inside the protocol. Now let's move on to subscript. I will bring this down here. Now in subscript, we have a separate video on subscript. If you haven't watched that video, I recommend you highly to go through it. You will know each and everything about subscript. Here we have a protocol and we are inside that giving the signature of subscript. And we have the structure string array, which is confirming to the protocol storage. Inside here, we have one property. I will remove this as we don't know about access modifier for now. So this is just a property items and it has values of type string and it's an array. Now we need an easy access to this property items here, right? What do? We use brackets and gain access to it. So whenever I will create the string array object here, that is storage, I will say storage and open the brackets, and inside that I will give index. So it will give me, if I give index 1, it will give me the index 1, which is P. So A is 0, 1, index 3, 2 for index 2 for C, and this index will be captured in here, and get block will be executed when you are reading this value, and set block will be executed when you are giving or assigning a new value. For example, here we are assigning Z to index 1. So Z will be coming inside a new value global variable, and we will just assign it to the property here and we'll provide the index. So at 1, that is 0, 1, here we will have Z. When we will read it again, here we'll get Z. And when we are mentioning how we mention the subscript inside the protocol is basically signature, that is the name subscript, the parenthesis inside that parameter, and the return type. We will mention this, and after that we have to mention the blocks as well, because subscript has get and set block, so we will mention them as well. And we can run it now. It will give us B and Z, and it gives us B and Z. Now let's move on to the next, which is initializer. Now when it comes to a class person1 I've created, and it is confirming to a protocol initializable, that is having an initializer here. So we have init keyword, and inside the parentheses we have a parameter name, and that's how we declare an initializer inside a protocol. Now this becomes a requirement, and any type which will conform to this protocol will have to implement it. So let's see, if a class conform to the protocol, it will have a property name, and because it has to implement an initializer init here, we have init implemented this way. Now you must be thinking, why do we have the required keyword here? Well, let's try removing it from here, and then you will see an error coming up here, that is initializer requirement init name can only be satisfied by a required initializer in non-final class person1. Now let's undo it first. Now what this error means is, because this class may undergo inheritance, other class can inherit person1 class, then this initializer will be um, also getting inherited. Since it is getting inherited, it is going to be mandatory for them to implement it. So we have to mark it as required. And this is only there for classes, because classes only has inheritance. Structure enum do not have inheritance. So we don't have to mark them as required here. If I will change it to struct and I remove it, and if I run it, it will give you Alice, that is this. If I give it 1 2 and run it again, it will give you Alice 1 2. But if I change it back to class, I have to have a required keyword here, otherwise you will see this error is coming up. So I will required, I will add it here, and let's run it again. And that's it. We are done with initializer as well. And let's move on to the next one, that is optional. So this is also very interesting. Now, when we talk about optional, optional is a keyword that we use inside the protocol, and this keyword we can use on a property of the protocol or a method of a protocol. To mark it as optional, that basically means that any time that will confirm to this protocol will not have to implement it. Let's see how it works. So I have a protocol here named vehicle4. Inside that I have one read-only computed property. I've written here required property because this is not marked as optional. So any type which will conform to this protocol will have to fulfill this requirement or will have to implement this property. Now let's see the next property, which is speed, and it is also a read-only computed property. Now if I will mark it as optional here by using an optional keyword, I will also have to use @objc keyword here along with the optional keyword, because this is available only, this optional keyword. We'll talk about it if it is available in enum and classes or structure also, but it is only available for classes. We'll see the reason why. Now, when we use this Objective-C and optional keyword together, objc by the way stands for Objective-C. When we use Objective-C keyword, then we have to mark protocol as well with objc keyword like this. And that's it. We have our protocol ready, inside which we have two properties. One is must for implementation and next is optional. Now here I have created so this is how we basically declare optional properties. Now let's see one example in which we will create not only optional property but also optional method. So here we have another protocol, greeter, inside which we have a function farewell, which is marked as optional, and at Objective-C of course comes along with the optional keyword. And there is another method, greet. Now this is required one. Now I am having this greeter being implemented by friendly person and also by a quiet person. Both are classes. Now here we are implementing both greet and farewell, that is required and optional. But here quiet person is implementing only greet. So it's basically what optional keyword means here, that this become optional. You can either implement it or it is your choice not to implement it as well. So this class choose to implement it and this class quiet person does not choose to implement it. When we create the object of both quite friendly person and quiet person here, nx is both the properties here. Here friendly person because has the implementation of farewell, it will give you some output, but the quiet person do not have any implementation of the optional method, then it will not give you any output. Now there are some key points to focus on, but let's run it first. So we will receive hello, nice to meet you. Receive hello, nice to meet you. Then we receive the goodbye, see you soon. And hello is something we're receiving, which is here. And this is the optional method, which is not implemented by quiet person, which is here. So we don't get anything. And also if you notice, we don't get any error. Now here we have some key points about optional requirement. First is accessing optional requirement. Since optional methods or properties might not be implemented by confirming type, they must be called using optional chaining, that is instance question mark method name or instance question mark dot property name. Here we are accessing using this way as well. Now coming to the second point. Now if we try, before we go to the second point, if we try with this, we will receive some sort of error. So always choose to access the optional method using this way and not this way. That is optional chaining, one of the ways we have seen to unwrap or basically access an optional method. So you will see cannot use optional chaining on non-optional value of type any greeter. If you try it with here as well, it will give you the error just like that. So I will undo this, and we should always prefer to actually go or access this way and not this way. I will still keep it here so that you know this is one way to unwrap an optional property and method, but when it comes to optional method inside a protocol and you want to access it. Now let's talk about second limitation to add objc. Optional requirements are not available for protocols meant for structure enums or generics types, because at objc is limited to classes and objc object-to-C interoperability basically. So it is only the interoperability of the objc keyword is only works with classes when it comes to optional. And the third one, which is the better alternative for purely Swift types, structure and enum, you can achieve similar functionality by providing a default implementation using protocol extensions. If you don't want a method to be implemented by the type which is conforming to that protocol, just give a default implementation inside the extension of the protocol. And that's it. We can go to the last type, which is the sixth associated type. We can mention associated type inside protocol. And again, not much here, but in the separate video we'll understand associated type and generics totally. So for here we'll be done, because in question 3, which is can we define method with body in protocol, it's pretty straightforward. No example needed as of now, because in previous examples we have already seen this very much in detail. And the fourth question is what all types of properties can we give in protocol? We have already seen it, only computed properties and type properties. So far all the examples that we have seen, we were using only computed property, and that too either read only computed property or read write computed property. That is get only computed property or get set computed property. And the type property, which is basically using static keyword in front of the property. And let's get back to our last example of this video. Associated type. So protocols can define placeholders types using associated type, which must be specified by confirming types. So whenever this confirming type is conforming to the container protocol which has the associated type in it, they must give the value to the associated type by writing type alias item and give it the type. And that's it, that we can use throughout our structure as well. Here I've created the object of the structure and we are accessing add element method. Let's run this. It will just add the element and it will then print adding item to container. It is throwing error at the moment. Okay, I have forgot to remove this here. Let's run it now. And we have received adding 4 to the container here. And that is it. I hope you find this video informative. If you have watched this video till the end, a big congratulations to you guys, because you know each and everything about protocols and extension. We don't have to take a quick recap as of now because this is all that we have learned here. If you ever feel the need of revising this once again, just open this file and go through all the pointers here mentioned here one by one. I've mentioned from the definition, that is the first, the second, and the third, and so on. And I've added comments as well to be explanatory at every point. Whatever we have discussed and that you have learned in this video, I've mentioned it in the form of a comment in between quotes. So this file is going to be very useful for you when you want to revise protocols and extension. I will see you in the next one.